Coming right out here, we have Dave Tillman talking about writing event-based microservices using Steeltoe. How's it going, Dave?
Good. How are you?
I'm doing great. Are you all ready?
I'm ready.
Take it
Let's do
away,
it.
sir. Go
All
for
right.
it.
Thank you. Um, yeah. So my name is Dave Tillman. I work for VMware, and I'm the tech lead on a project called Steeltoe. And so today, what I'd like to do is take a few minutes and talk about Steeltoe, the project itself, because I'm guessing there are a few people on the watching today that probably aren't fully aware of what Steeltoe is. Talk a little bit about microservices, and then what we're going to focus on today is something we added in Steeltoe 3.0, which is support for messaging-based systems. And we'll talk about how you can use that in building microservices that are event-based. So first of all, a little bit about the Steeltoe project. Steeltoe project was started, I actually started this back in Pivotal when we were at part of Pivotal Software about almost 5 years ago now. And right now, Pivotal was acquired recently by VMware. So now the project is actually sponsored by VMware at this point. We're a small group. We started like I said, about 5 years ago. We currently have about five, we call them toes, five toes on the team right now. And that's including Jason, who we refer to as the big toe. He's our engineering manager. So we basically have four developer toes on the team right now. Now we are looking to grow, and in fact, we're looking to add some more toes to the team. And so if you're interested, check out VMware's website, look at the career website, and put an application in if you're interested. We've also been getting more and more community support recently, lots of community contributions. And so to those of you that are watching that have been contributing to the Steeltoe project, we want to thank you and thank you a lot. And so if you're kind of new to the Steeltoe project and you'd like to get involved, that's a great way for you to come over and give us a hand. Everything is listed there on the screen there for where the project is hosted, and we welcome contributions all the time. We another thing, another milestone that happened in the Steeltoe project is we joined the .NET Foundation roughly around 2018, I believe it was, and we contributed the code to the foundation. And so now the code is part of the foundation, and of course it's licensed back to all of you out there that want to make use of it under Apache 2.0 license. So it's freely available, freely usable. We support both .NET Full Framework as well as .NET Core. We have a 2.x project line of code that is supporting the full framework and .NET Core, and then our 3.0 line of code is now supporting pretty much only .NET Core. We are working on .NET 5. We've done some testing and it's looking pretty good, and so we feel like we'll be able to get .NET 5 support here pretty shortly. We have lots of samples out there to get started from. We've got we have help and documentation out there for you as well, and then you can always reach us at Slack. Now at this point you're probably wondering, okay, well, what is it that you guys actually do? And so let me go into a little bit about the Steeltoe project and its mission when we kicked this off almost 5 years ago. Our focus is building, essentially enabling developers to build production-grade microservices. And there are a lot of packages, a lot of projects out there, a lot of frameworks that kind of claim the same thing. So here's a few things that make us a little bit different than what you might find out there that you could also use as well. And one of the things that we are focusing on is we are focused on providing packages that implement some commonly used patterns in building distributed systems. And whenever you embark on building out applications using a microservices architecture, essentially you're building a fairly large, you could be building a fairly large, complex distributed system. And so over the years, there are a set of patterns that have been adopted and used by developers and architects over the years on terms of best practices that you should follow. Things like, for example, externalized configuration or service discovery, circuit breaker. Many of you probably have heard of some of these patterns. And so what we've done is we've brought to bear a bunch of packages that we have developed that you can then leverage and use in your microservices in order to build what we would refer to as production grade microservices and production grade microservice applications. So the other thing, there's a bunch of them, and I'll show you some more of what we provide today out of the box here in a little bit. The second thing that we focus on is we focus on abstractions, as I've got listed here. Our idea is that you write your .NET code and you can run it on any cloud platform. And we're trying to provide abstractions for the various cloud platforms. And when we started out, we were really focused on something called Cloud Foundry, which was something that was produced out of Pivotal Software and is now part of VMware. And in fact, it's been rebranded now as TAS, Tanzu Application Service. And so when we started out, we kind of focused mostly on that. But now in the more recent times, in the last year or so, we've been really trying to focus more and more on trying to provide abstractions on top of various cloud-based services so that you don't get locked into any particular cloud-based technology or underlying technologies that you might be using on the cloud, on those cloud platforms. The third thing that we are trying to focus on is making sure that you can build polyglot-based applications. Microservice-based applications. So when we started out, like I said, about 5 years ago, we were really focused on Cloud Foundry and trying to make that cloud-based platform a great place to run .NET applications. And Cloud Foundry is actually used by some very large Fortune 500 companies to run their data centers today. And as we were working with those companies, we found that in addition to .NET, many of them were using Java and in fact, Java Spring. We're building essentially a combination of both Java-based microservices as well as .NET-based microservices. And Java Spring is a very popular framework that large enterprise customers use today to build out these microservice-based applications. So what we decided is that we would begin to implement a common set of these patterns, these distributed systems patterns, both in Java and .NET, so that and then we would ensure that we would get out of the box integration with our Java Spring counterparts as well as the .NET counterparts. And so, for example, if you take externalized configuration, where you essentially take the configuration of your application and externalize it, put it into something called a config server. We've implemented that in such a way that you can configure both your Java-based microservices as well as your .NET-based microservices in the centralized configuration store, and you can access them in the same way seamlessly between the two worlds. And those ideas, like I just described, carry on through all of the basic patterns that we've implemented for microservice-based development. And then the last thing that we are focusing on is building out developer productivity tools. And we're trying to essentially make it very easy for developers to stand up, test, and debug microservices-based applications. Do it at the desktop, run and do your testing, and then very easily deploy and push up to the cloud-based platform that you might be using seamlessly without making any configuration changes if possible, or certainly no code changes. And so those are the kind of things that we've been focusing on for the last 4 or 5 years. Here's a list of components and the kind of the areas in which we are focusing on and have implemented packages for. We've actually gotten quite a few components out there today, everything from dealing with things like observability, as well as scalability, circuit breaker patterns, bulkhead, client-side load balancing, the list goes on and on and on. But what I want to speak to you about today is in the area of what we call integration kind of services, and specifically about messaging. And this is something that we recently added in into the 3.0 code base, just released not too long ago. Now, before I jump into the details of messaging, I want to take some time to kind of do a level set on terminology, on concepts, and make sure that we're all talking about the same thing and thinking about these terms in the same way. So let's first just kind of level set on microservices. I think probably everybody that's watching today has a pretty good understanding of what this is, what microservices are, but it's essentially a way in which you want to embark on structuring your applications going forward. And so on the left, you see a diagram or a set of symbols that illustrate a monolithic type application where you have a process that has all of the various services inside of it deployed on a VM or somewhere, and you've got a database that has all of the database objects in it, and you've got this kind of intertwined mess and then of course where you're trying to move to is the architecture or the structure that you see on the right, where we're now deploying or configuring or building this application in such a way that we're building it around microservices. Each microservice is a self-contained, has a well-defined API and has a very specific purpose. For example, you might have a microservice that deals with the customers. You might have microservices that deal with orders. They manage their own data, so you no longer have this large back-end database that's all webbed together. They're all of the microservices are independently deployable and scalable, as well as testable. You typically have tight coupling on the inside of the microservice, but much more looser coupling on the outside. And just by the nature of the fact that each of these microservices kind of run in their own process, typically, may even run in their own VM, it kind of begins to enable a polyglot-based application. You could easily see one of those components being written in Java Spring and another one being written in .NET Core or .NET 5, for example. But now once we begin separating these things into separate processes, separate VMs, of course, now we have to use some sort of IPC type technology in order for the microservices to interact with one another. And so, typically we're talking about things like HTTP REST, which we all have used, I'm sure, on this call, as well as things like gRPC, JSON, XML, et cetera, et cetera. Now, before I go into the details of the technology, the IPC technology, let's talk a little bit more about the interactions, the types of interactions that microservices have between each other. And there's this really great book that I find quite useful at times, many times, written by a gentleman by the name of Chris Richardson. It's called Microservices Patterns, and he takes time to break down the interaction styles that he has seen between different microservices out there. And he looks at it in a two-dimensional way. On the top, we see that microservices will interact with one another either one-to-one or one-to-many. And then down the other side, we see they typically will either interact in a synchronous way or in an asynchronous way. And then within each one of those, then he characterizes them as, whether the request reply and labels them as such. So the request reply synchronous type communications that we typically see between microservices, that's normally something like a remote procedure call where you're invoking a client is invoking a backend service, and it's usually blocking or waiting for the reply in order to continue on its execution. Alternatively, we have another interaction style which is more asynchronous based, where the client doesn't block. It does not expect necessarily an immediate reply, although it could. And in fact, it may not even get a reply at all. And we typically use a messaging technology in order to implement that type of interaction style. Now, what we find out there is that when you're building microservices, you're going to find that you end up implementing a combination of all of these sorts of interaction styles. In other words, a microservice will both implement as well as make use of all of these different types of interaction styles. So let's drill into the synchronous and asynchronous interaction styles. I think everybody probably understands the one-to-one or the one-to-many style. It's probably not too complicated and too controversial. So let's look at both the synchronous and the asynchronous interaction styles. The synchronous one, many of us have used over and over and over again in building microservices. It's familiar to us as developers. The request reply is like a method call, and it's very easy for us to understand and to make use of. It's mostly used in one-to-one interactions between a client and a backend service. And it typically then, once you begin to go down this path in implementing something like this, it really begins to put together a tight runtime coupling that exists then between those two microservices. And so what that means is that both ends must be available at runtime in order for that request and reply to actually work. And by using this style or this interaction style, the overall app availability can be reduced because of this need to have both ends up and running and available. And in fact, typically what you find is when you're using this style of interaction is you typically, in order to build really a production grade type application built around these kinds of, built around microservices using these interaction styles, you end up using some additional patterns like I mentioned earlier in order to make them production ready. So things, for example, like service discovery is necessary because these microservices can come and go, and that in order for the client, in order for it to interact with the service, the other service and directly interact, it has to have the address, if you will, or the coordinates by which to reach out and communicate to that. And so in order to deal with the dynamism that happens by microservices coming and going, spinning up and going away, or having multiple of them out there ready to handle requests, you end up using this service discovery pattern in order to deal with it. Likewise, things like circuit breaker, bulkhead pattern, client-side load balancing, these are all technologies or patterns that you typically employ when using this synchronous remote procedure call type interaction style. Steeltoe provides today packages that you can use in order to implement these patterns when you're using a synchronous remote procedure call technology. Now, if we switch over to the async messaging style, here we typically see a message broker being used as an intermediary. Doesn't have to be, but in most cases, that's typically what you find. And the message broker then provides some sort of channel or some sort of abstraction by which clients and servers can send now messages from one to the other. And with this kind of model, you have less runtime coupling, as you can see, because the client and the server, client and service are not really interacting directly with one another. They're interacting through this intermediary, this message broker. And we typically send something called a message from one to the other. And a message consists of a header plus some sort of payload, some sort of, might be a byte array, it might be an object, JSON based stream object, whatever it may be, that's being used to communicate from one to the other. And this model, this async messaging model, is flexible enough to support both one-to-one and one-to-many interactions. And in fact, you can even do synchronous request reply interaction style if you want to, using underlying messaging technologies. Then also you also get some advanced scenarios. Like, for example, you get the ability to do things like partitioning and sharding kind of functionality as provided by the by the message broker. You get to implement something called competing consumer. These are all patterns that you can leverage in building out a very highly scalable message-based application. But with it comes added systems complexity. Of course, you now have potentially a performance bottleneck with the message broker as being the intermediary. It could also be a single point of failure if the broker is not clusterable and resilient. So there's some more additional complexity that you get as well when you adopt this kind of technology. Now, in addition to the interaction styles that you have between microservices, there's also something that has also been looked at, and that's the categorization of the interactions between the microservices. And so in the next slide, some people much smarter than me and have a lot more experience building microservices have come up with 3 basic categories by which you can group together, if you will, the functionality that's exposed by the microservices-based APIs. And those are listed here: commands, queries, and events. And any given microservice may use or implement any one or more of these kind of categories. And so let's think about these categories a little bit more. For example, commands are essentially intended to when one microservice interacts with another one and issues a command type interaction, we're essentially talking about trying to cause that microservice, that receiving microservice, to execute some business process or task, and then typically will return a result for you as a result of that. So for example, something like a create order or create customer would be an example of a command like microservice. And you can use either synchronous or asynchronous request reply, and it's typically an interaction style that's one-to-one. Between when you're using or implementing or actually making use of other commands from one microservice to another. Then we also have this other type, which is called a query, and this is where you're basically asking a microservice to provide some information or some data. And so things like find order or find a customer order are examples of that. Many times you'll see people will group together both commands and queries into what are referred to as the operations that a microservice implements or makes use of, say, downstream as well. And then the third area of categorization are something called events. And this is where a microservice is sending out, for example, communicating that something has happened or changed. So, for example, a customer has been deleted or an order has been created. These are examples of these kind of events, sometimes referred to as domain events. And you can typically use a asynchronous request with no reply kind of interaction style in order to, in essence, publish events. And it could be either one-to-one, or typically you see it's a one-to-many, where we're using more of a pub sub style distribution of those events. So let's take a look at an example of where as a few. I think I've got 3 microservices where we implement something called a CQRS microservice pattern, and how you can use these both commands, queries, and events in order to implement that pattern. So CQRS stands for Command, Query, Responsibility, Segregation. And it's a pattern useful in implementing data queries in a basically queries in a microservices-based architecture. And it's all about the segregation part of it, where instead of instead of a microservice implementing both the commands and queries, we end up segregating out the queries into a separate microservice, and the other microservices in fact just implement commands and potentially maybe events. So let's use an example here. Imagine a couple microservices shown there on the left, customer microservice and an order microservice. Remember, microservices own their own data, so we have orders and customers being owned by each of the microservices by themselves. And imagine you need to implement a query that is to find a customer's orders. And so, you know, you can't just do a find on the order microservice or a find on the customer. Basically, you have to do a join across the data now that's now separated and held by each microservice independently. And there's a couple different ways that you can, couple different patterns that you can use to implement that kind of a query where you're trying to find find all the orders, for example, for a given customer. And one of those is a composition pattern where you can put a microservice in front of the customer and order microservice and basically leave the queries over on the order and the customer, and then have the composition microservice essentially query the customer, query the orders, et cetera, and do a join, if you will, in memory in that microservice. And sometimes that's fine. That works quite fine. But for large data sets, it might be real problematic depending on the types of joins and the types of queries that you're doing. So the other approach to handling this issue is to use this CQRS pattern. And this is a pattern where now we separate out the queries from the customer and order and put them in its own separate backend, what I refer to as another backend service that's kind of sitting behind the orders and customer microservices. And we use events in order to communicate creation and updates of both orders and customers. And those events essentially are sent over a messaging infrastructure, like a message broker. And the new service sitting in the back end there, called the customer order service, will take those events and create a database that is then queryable by other microservices, and essentially we'll be able to do the joins and do a much better job depending on the database and the amount of data you're dealing with, and can then use whatever database technology that you'd like to use on the back end. And so here we see these domain events coming out of each of the customer and the order microservice being sent into the message broker as these events happen, and then the customer order microservice is receiving them and then updating the database on the back end and providing the queries to any upstream microservices that might need to make use of it. Now, of course, this adds some complexity to an overall application. One of the things you have to deal with, of course, is the replication lag time that might exist when orders or customers are updated. But in some cases, depending on the application, that may be quite workable. So what I'd like to do now is begin to take some time and look at how Steeltoe provides the underlying, can be used to provide the underlying mechanisms for essentially sending these events through a message broker to this customer order service. And this is something we added in the 3.0 release of Steeltoe that happened a little over a month ago, I believe it's been. So, as I mentioned earlier, Steeltoe is all about abstractions. And so one of the things that we did in the 3.0 timeline is we put in place several abstractions, some of which I'm showing here, to represent essentially APIs that you would use in your .NET application in order to communicate these events or messages to other microservices. And the idea behind these abstractions is to shield you from the underlying, if you make use of these abstractions, to shield you from the underlying messaging technology that is being employed in order to send these messages from one microservice to another. And so, we define things like a message. You'll see in the code coming up that we have something called an iMessage that we build on. We have an iMessage header. We have message builders that help you build messages. And then we have these things called message converters that will convert the underlying message, iMessage headers, into whatever the underlying messaging system types that are used by that particular messaging infrastructure. And then we've also provided a bunch of attributes that are used when you're defining methods that are going to actually receive the incoming messages. Attributes that are used for pulling out, say, out of the message, pulling out header values, et cetera, et cetera. And then what we've done is with Steeltoe messaging, then we've added specializations and implementations for each of the underlying messaging systems that we support. Today, we support RabbitMQ out of the box. You'll see that we plan on also adding Kafka support in the future. All right, so since we're focusing on RabbitMQ initially with Steeltoe, I wanted to take just a real quick minute to explain a few of the basics associated with RabbitMQ. So, for example, notice we have exchanges, queues, and bindings. These are the components that are used by Rabbit for interacting with the Rabbit system. And so you'll see in the APIs, when I go forward here, you'll see in the APIs that when you add the Rabbit services into your container, you'll be using you'll be referencing these sorts of objects. So here is an example of the code that's needed in order to add the RabbitMQ services into the container. And then we have out-of-the-box message converters that can be used to convert messages from one type to the other. And we have both .NET binary messaging as well as JSON as well for interacting. And then when you need to send messages, we have something called a Rabbit template that can be used in order to send messages from one component to another. And you're able to use both domain objects with the convert and send, as well as you can just send raw iMessages down the pipe as well. Here's a quick slide that shows the messages that and the APIs that you can use to create messages. And we support all of the different interaction styles that I was talking about earlier, things like sending requests with no replies, as well as sending requests with replies. All the different interaction styles are possible. In fact, you can even just receive with no replies as well. And then when you need to go ahead and process messages, you can define a message listener and attribute the method with the details of what you'd like to connect to, and we handle automatically the spinning up of the container, not a container like your Docker container, but the container that will process the incoming message for you, and will do handling of message conversion, et cetera, et cetera. And then finally, we have support for the Rabbit admin API, which allows you to declare queues and exchanges and everything automatically upon startup. Makes it very easy for you to spin up and get queues and exchanges declared. And there's many different ways you can use attributes in order to declare the queues, as well as you can use imperative programming in order to do the same as well. Here's our futures, where we're headed. We're adding Kafka support in the very near future. We're building on and adding additional cloud platforms like Azure and GCP and AWS. And then we're also building on a streams-based programming model on top of it. And we plan on supporting Spring Cloud data flow as well in the 3.1 timeframe. And so that is a data processing, data pipeline orchestration engine that you'll be able to use with your .NET components as well as Java. We won't have time for a demo. I'm way over. I want to thank you very much for joining. Hopefully you've gotten some things out of it, and please come by over to our project on GitHub and or over on Slack. Thank you.
Thank you for taking the time. Yes, we're a little bit over, so no worries. Thank you so much. It was a lot of great content.